Hello, my name is Edwin Hawkins. I'm here to talk to you about my course of study at Central Georgia Technical College, which is the Associates of Applied Science for GIS. GIS is Geographic Information Systems. What comprises GIS? According to ESRI, GIS is a collection of computer hardware, software, and geographic data used for capturing, managing, analyzing, and displaying all forms of geographically referenced information. In other words, simply put, GIS is a collection of data that has a spatial reference to it. In this case, we got a satellite image, we got a GPS digital data collector, we use aerial photography, we use hardware and software, which in our case is a computer, and a piece of software that we utilize at Flint Energies called ArcView. We have digital maps. We have tabular data, which a lot of times is either an Access database or an Excel spreadsheet, some type of information that we need to collect or we need to put together and show on the map. You heard me mention spatial data. Spatial data is a term that's used in the GIS community, and you're going to continually hear it anytime you talk to anybody in GIS. Simply put, spatial data is spatial reference, is data sets which are spatially referenced to a location on the Earth. Data sets which can be combined and used for analysis such as soils, land use, agricultural pollution potential. We use poles, transformers, switches, we have the consumers. We roughly cover 17 counties, and we have over 85,000 consumers. We have over 115,000 poles. We've got over 40,000 transformers, and we use a GIS system to keep track of all of this information. We turn around, we're able to, because this data is spatially referenced, we're able to overlay on top of each other this type of data, such as the poles, the distribution lines, and the consumers, and make educated guesses or educated decisions based on this data that we have collected and the attributes collected with them. One case that comes to mind is we have a lot of transformers out in the field that didn't have anybody attached to them over the years. People would leave, or we would build a subdivision, and the transformer would never get attached to a house because the developer would never develop a house, especially with the economic downturn. The subdivisions just didn't develop. So we were able to lay our transformer layer on top of our subdivision layer, put our primary distribution line on top of that, and be able to go in and determine which transformers were not actually connected to a consumer. We're able to go out, send our teams out to pull those transformers out of the field, so we didn't pay taxes on items that were out in the field that weren't being used, thereby getting what they call a return on investment on our software, and pull money, pull these items back into the field, reuse them in other places, and save the community and their members money. In order to collect this type of data, often we'll use a GPS unit. This particular GPS unit is a little bit different than the one that you purchase when you go out to Walmart or Best Buy. This particular GPS unit has what we call sub-meter accuracy, and that's why we use it for mapping. It's also referred to as mapping grade accuracy. The little E-Trex Legend or the recreational sport GPS unit that you use gets you to within 15 to 45 feet of the point. This unit right here will get us to within less than 3 feet of the point that we collect. This is very important to us so that we can provide accurate data to our GIS technicians so that they can pull this data up, use it to make educated decisions, in turn save the company money. By saving the company money, we save our members money. By saving our members money, it actually saves on their cost of electricity. That's how we use GIS here at Flint. I appreciate your time. My name is Ed Hawkins. Thanks a lot.